We have already discussed the applications of the PLL. PLL can be used as a frequency multiplier. Example, if the input signal frequency is 1 kilohertz. 1 kilohertz means this signal is repeating 1000 times per a single second. This signal is repeating 1000 times per a single second. That is 1 kilohertz signal. And the time period of this signal is 1 millisecond. Now we are expecting a 2 kilohertz signal. I want to change the frequency of the signal from 1 kilohertz to 2 kilohertz. Means I am expecting this signal has to appear 2000 times per a single second. So now the frequency is changed here. This is a 2 kilohertz signal. And you observe the time period here is 1 millisecond. And the time period here is only half millisecond. You can observe the change in the width. Compared to this is exactly half. In order to generate this kind of signal, the time period is half and frequency is double. We are using a PLL. Not only this, we can even generate a 4 kilohertz signal, or 6 kilohertz signal, or 8 kilohertz signal, or 10 kilohertz signal, or n kilohertz signal. That's why we are calling this as a frequency multiplier. But now we will discuss how we are generating a 2 kilohertz signal from the 1 kilohertz signal. We know in the PLL we have the phase comparator and the low pass filter, error amplifier and VCO. But now we are adding an additional block, percentage n or division of n network. Here this network we are connecting between pin 4 and pin 5. We discussed already, generally we will short 4 and 5 pins. But here we are intentionally keeping this network between the pins 4 and 5. Now the VCO output is connected to this percentage n network or division n network. Example, in this case, the input signal frequency is 1 kilohertz. The input signal frequency is 1 kilohertz. The VCO center frequency is also 1 kilohertz. Now we are using example a network. It is percentage n network. So if I am using 2, then this will be output will be 500 Hz signal. 500 Hz signal, remember. Even though the VCO output is 1 kilohertz signal, when it comes to here it will be 500 Hz signal only, because we are dividing it with by 2. Now the phase comparator compares the difference. The input is 1 kilohertz, here the VCO output is 500 Hz. Actually the VCO output is 1 kilohertz, but because we used this network, now the VCO output is 500 Hz. Now there is a more difference. DC output will be generated exactly accordingly proportional to this difference, and then we are using low pass filter, error amplifier. Now the VCO frequency will be adjusted to 2 kilohertz in order to acquire the locking condition. Because this is 2 kilohertz, now the output of this network will be 1 kilohertz. Now the input signal is now the PLL is in lock condition. Because here input signal also 1 kilohertz, here this is also 1 kilohertz. But that is not relevant to us. What that is relevant to us? PLL, here the VCO center frequency is 2 kHz. We can take this 2 kHz from the pin number 4. That's why we have kept pin number 4 as an output. There you can take the output 2 kHz signal practically. In the LM 565 we have discussed. From this pin number 4 you can take the 2 kHz signal. Example, if you want 4 kHz signal, then this N we have to keep 4. If you need 8 kHz signal, then what is the N value we have to keep? 8. So from the 1 kHz signal, we can generate 2 kHz or 4 kHz or 8 kHz signal. That's why we are calling this as a frequency multiplier.